Hello, welcome. The topic of this video will be about the F-22 Raptor, which is considered the best fighter aircraft of all time. The Lockheed Martin F-22 Raptor is an American single-seat, twin-engine, all-weather tactical stealth fighter aircraft developed for the United States Air Force, USAF. As a product of the USAF's Advanced Tactical Fighter (ATF) program, the aircraft was designed as an air superiority fighter, but also incorporates ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems and conducted final assembly, while Boeing provided the wings, aft fuselage, avionics integration, and training systems. The aircraft first flew in 1997 and was variously designated F-22 and F/A-22 before it formally entered service in December 2005 as the F-22A. Although the USAF had originally planned to buy a total of 750 ATFs, the program was cut to 187 production aircraft in 2009 due to high costs, a lack of air-to-air missions at the time of production, and the development of the more affordable and versatile F-35. The last F-22 was delivered in 2012. While it had a protracted development and initial operational difficulties, the F-22 has become a critical component of the USAF's tactical air power. The fighter's combination of stealth, aerodynamic performance, and mission systems enabled a leap in air combat capabilities and set the benchmark for its generation. The F-22 is expected to serve into the 2030s and eventually have its role succeeded by the USAF's Next Generation Air Dominance (NGAD) manned fighter component. Avionics. An F-22 releases a flare during a training flight. The aircraft has an integrated avionics system where, through sensor fusion, data from all onboard sensor systems as well as off-board inputs are filtered and processed into a combined tactical picture, thus enhancing the pilot's situational awareness and reducing workload. Key mission systems include Sanders/General Electric and /ALR-94 electronic warfare system, Martin Marietta and /AAR-56 infrared and ultraviolet missile launch detector, MLD, Westinghouse/Texas Instruments and /APG-77 active electronically scanned array, AESA, radar, TRW communication/navigation/identification, CNI, suite, and long-range advanced IRST currently being tested. The F-22's baseline software has some 1.7 million lines of code, the majority involving the mission systems such as processing radar data. The integrated nature of the avionics, as well as the use of ADA, has made the development and testing of upgrades challenging. To enable more rapid upgrades, the avionics suite added an Open Mission Systems (OMS) processor, as well as an open-source Kubernetes platform called the Open Systems Enclave (OSE), to enable the use of containerized software from third-party vendors. The F-22's ability to operate close to the battlefield gives the aircraft threat detection and identification capability comparative with the RC-135 rivet joint and the ability to function as a mini AWACS, though its radar is less powerful than those of dedicated platforms. This allows the F-22 to rapidly designate targets for allies and coordinate friendly aircraft. In 2007, the F-22's radar was tested as a wireless data transceiver, transmitting data at 548 megabits per second and receiving at gigabit speed, far faster than the Link 16 system. The APG-77 radar has a low observable, active aperture, electronically scanned antenna with multiple target track while scan in all weather conditions. Radar emissions can also be focused to overload enemy sensors as an electronic attack capability. The radar changes frequencies more than 1,000 times per second to lower interception probability and has an estimated range of 125 to 150 mil against an 11 square foot target and 250 mil or more in narrow beams. The upgraded APG-77V1 provides air-to-ground functionality through synthetic aperture radar mapping and strike modes. Alongside the radar is the ALR-94 electronic warfare system, among the most technically complex equipment on the F-22, that integrates more than 30 antennas blended into the wings and fuselage for all-round radar warning receiver (RWR) coverage and threat geolocation. It can be used as a passive detector capable of searching targets, with range exceeding the radar's, and can provide enough information for radar lock and cue emissions to a narrow beam, down to 2 degrees by 2 degrees in azimuth and elevation. Depending on the detected threat, the defensive systems can prompt the pilot to release countermeasures such as flares or chaff. The MLD uses 6 sensors to provide full spherical infrared coverage, while the advanced IRST, housed in a stealthy wing pod, is a narrow field of view sensor for long-range passive identification and targeting. To ensure stealth in the radio frequency spectrum, CNI emissions are strictly controlled and confined to specific sectors, with tactical communication between F-22s performed using the Directional Inter/Intraflight Data Link (IFDL). Radar and CNI information are processed by 2 Hughes Common Integrated Processor (CIP)s, each capable of processing up to 10.5 billion instructions per second. The aircraft has also been upgraded to incorporate an automatic ground collision avoidance system (GCAS). Cockpit. Cockpit of the F-22, showing instruments, head-up display and throttle top, lower left. The F-22 has a glass cockpit with all digital flight instruments. The monochrome head-up display offers a wide field of view and serves as a primary flight instrument. Information is also displayed upon 6-color liquid crystal display, LCD, panels. The primary flight controls are a force-sensitive sightstick controller and a pair of throttles. The USAF initially wanted to implement direct voice input, DVI, controls, but this was judged to be too technically risky and was abandoned. The F-22 has integrated radio functionality. The signal processing systems are virtualized rather than as a separate hardware module. The Integrated Control Panel, ICP, is a keypad system for entering communications, navigation, and autopilot data. The F-22 has a complex life support system, which includes the onboard oxygen generation system, OBOGs, protective pilot garments, and a breathing regulator/anti-G, brag, valve controlling flow and pressure to the pilot's mask and garments. The pilot garments were developed under the Advanced Technology Anti-G Suit, ATAGS, project and protect against chemical/biological hazards and cold water immersion, counter G forces, and low pressure at high altitudes, and provide thermal relief. Following a series of hypoxia-related issues, the life support system was consequently revised to include an automatic backup oxygen system and a new flight vest valve. In combat environments, the ejection seat includes a modified M4 carbine designated the GAU-5/A. Armament: 1 AIM-120 AMRAAM, right, and 4 GBU-39 SDB, left, fitted in the main weapons bay of an F-22. The F-22 has 3 internal weapons bays, a large main bay on the bottom of the fuselage, and 2 smaller bays on the sides of the fuselage, aft of the engine inlets. A small bay for countermeasures such as flares is located behind each side bay. The main bay is split along the centerline and can accommodate 6 LAU-142/A launchers for beyond visual range, BVR, missiles, and each side bay has an LAU-141/A launcher for short-range missiles. The primary air-to-air missiles are the AIM-120 AMRAAM and the AIM-9 Sidewinder, with planned integration of the AIM-260J ATM. Missile launches require the bay doors to be opened for less than a second, during which pneumatic or hydraulic arms push missiles clear of the aircraft. This is to reduce vulnerability to detection and to deploy missiles during high-speed flight. An internally mounted M61A2 Vulcan 20mm rotary cannon is embedded in the airplane's right wing root with the muzzle covered by a retractable door. The radar projection of the cannon fire's path is displayed on the pilot's head-up display. Although designed for air-to-air missiles, the main bay can replace 4 launchers with 2 bomb racks that can each carry 1,000 pounds or 4 250-pound bombs for a total of 2,000 pounds of air-to-surface ordnance. While capable of carrying weapons with GPS guidance such as DAMs and SDBs, the F-22 cannot self-designate laser-guided weapons. F-22 with external weapons pylons. While the F-22 typically carries weapons internally, the wings include 4 hardpoints, each rated to handle 5,000 pounds. Each hardpoint can accommodate a pylon that can carry a detachable 600-gallon, 2,270 L external fuel tank or a launcher holding 2 air-to-air missiles. The 2 inboard hardpoints are plumbed for external fuel tanks. The 2 outboard hardpoints have since been dedicated to a pair of stealthy pods housing the IRST and mission systems. The aircraft can jettison external tanks and their pylon attachments to restore its low observable characteristics and kinematic performance. Stealth. For stealth, the F-22 carries weapons in internal bays. The doors for the center and side bays are open. The 6 LAU-142/A AMRAAM vertical eject launchers, AVL, are visible. The F-22 was designed to be highly difficult to detect and track by radar. Measures to reduce RCS include airframe shaping such as alignment of edges, internal carriage of weapons, fixed geometry serpentine inlets and curved vanes that prevent line of sight of the engine faces and turbines from any exterior view, use of radar-absorbent material, RAM, and attention to detail such as hinges and pilot helmets that could provide a radar return. The F-22 was also designed to have decreased radio frequency emissions, infrared signature, and acoustic signature, as well as reduced visibility to the naked eye. The aircraft's flat thrust vectoring nozzles reduce infrared emissions of the exhaust plume to mitigate the threat of infrared homing, heat-seeking, surface-to-air, or air-to-air missiles. Thanks for watching. See you in the next defense and technology video. Bye for now.